In 2010, the 6 states that make up the Chesapeake Bay watershed committed to improving the water quality of the Chesapeake Bay. Their projected improvement plan is estimated to cost upwards of $27 billion. With such an astounding projected cost, it's not surprising that many of the 17 million affected citizens have wondered if we're simply dumping billions of dollars into the bay and hoping for the best. The goal of my research is to help ensure that our collective investment will actually result in a cleaner bay. The policy that the Chesapeake Bay states have implemented to improve water quality of the bay is focusing on reducing pollution in an effort to increase oxygen in the water. Just like us, a lot of animals in the bay require oxygen to survive. A lack of oxygen can cause severe issues for them, suffocating them, and sometimes resulting in fish kills like the one pictured. To figure out how to best improve oxygen levels in the bay, government scientists developed a sophisticated model. The kind of model they developed is a computer system that mixes both mathematical equations and environmental observations to figure out what the Chesapeake Bay will look like in the future. The primary issue with this method is that models can only offer predictions, and predictions can be wrong. However, a set of models can give us a set of predictions that can better help us figure out what the Chesapeake Bay will look like in the future. Many people are already actually very familiar with this concept. Take these hurricane track predictions for Hurricane Sandy made 4 days before she hit New Jersey. Each of those small lines in the middle is a prediction of the future made with a computer model. As the models predict further into the future, they begin to disagree on where exactly Sandy will make landfall. However, if we examine all the models together, we can get a much better sense of where Sandy is likely to make landfall, New Jersey, and where she's not likely to make landfall, Bermuda. So taking this multiple model framework together, the multiple models help us understand the variety of possible future outcomes. Now, to take us back to the Chesapeake Bay, the Environmental Protection Agency has relied on a single modeling system to figure out how to best introduce or increase oxygen levels in the bay. My research is going to take part of that government model and add a set of academic models to figure out where the models agree that oxygen levels are going to increase and where the models don't agree that oxygen levels are going to increase. A final product of my research is going to look like something like the map, where the green and yellow areas would indicate places where all the models generally agree that our efforts will increase oxygen, and the red and orange areas would indicate places where the models disagree that our efforts are going to increase oxygen and identify places that require further research. The ultimate cost of cleaning up the Chesapeake Bay is not going to be borne equally among the 17 million citizens. The goal of my research is to help ensure that our effort in all dollars, grit, science, and everything else are actually used effectively. So rather than feeling like we're dumping billions of dollars into the bay and crossing our fingers, we can increase our confidence that our efforts will actually result in a cleaner bay. Thank you.